So this question is about gives information on three lines observed in emission spectrum of hydrogen atom. So these are the wavelength corresponding to their photon energy. So complete the figure 2.1 by calculating the photon energy for the wavelength of 486 nanometer. So we have to use E equals to hc over lambda. So c over lambda is the frequency, so it's the same formula as hf. So putting the values 6.63 into 10 to the power negative 34 into the value of the c, which is 3 into 10 to the power 8 meter per second, divided by the wavelength, which is 486 nanometer. So 486 into 10 to the power negative 9. So putting all these values and calculating it, we get an energy value E equals to 4.09 into 10 to the power negative 19 joules. As this 10 to the power negative 19 is already written in the table heading, so we'll write it as only 4.09. The part B says figure 2.2 is a partially completed diagram to show energy levels of a hydrogen atom. So this is 3.03 and 656 millimeter. It's a mistake, it is nanometer. So an energy level with a higher value, that is 4.09, we can draw it here. So that has an energy of 4.09 into 10 to the power negative 19. So a transition which actually originates from this point to the bottom will give us a wavelength, a shorter wavelength, because it has a higher energy, so shorter wavelength of 486 nanometer. So this is 486 nanometer photon. Now the third photon is an energy is emitted with an energy of 1.06, but we cannot draw energy level at 1.06. If we draw it, that violate the question, because it says only one further, so we are drawing it the 2, which is not right. So how we can get an energy of 1.06? So if we look closely, the energy gap between 4.09 and this 3.03 is 1.06. So this second arrow represent a wavelength of 1880 nanometer, which is given in the statement. So these are the two a single energy level which give us the both photons, 1880 nanometer and 486 nanometer. If it jumps to the ground level, that's it will emit a photon of 486 nanometer, but if it jumps to this 3.03, it will give us a photon of 1880 nanometer with 1.06 into 10 to the power negative 19 joule of energy.